My dear students, a very good morning to all of you. Today we are doing questions and answers from Aviation Meteorology, and our chapter is Atmosphere. Alright, so what does this question say? How does the height of the tropopause normally vary with latitude in the northern hemisphere? Now what do you understand by northern hemisphere? The area above the equator is the northern hemisphere, area below equator is the southern hemisphere. Alright, so here in the northern hemisphere this is 0 degrees. Let's say this is 45 north and poles is 90 north. Alright, okay, so just tell me, how does the height of the tropopause vary? Yes, what is your answer? It remains constant or does it change? It changes, yes. So how is it changing? Equator is south and the hemisphere is north, the poles is north. So when we are going from south to north, then what is happening? It is decreasing. So your answer is A. It decreases from south to north. Does it make sense? No? No? See, how does the height of tropopause normally vary with latitude? So it so height of the tropopause decreases from equator to poles. In equator it is 16 kilometers, 16 to 18. Near the pole it is 8 to 10. Yes. So in the northern hemisphere, the southern side is your equator and the northern side is your pole. In the southern hemisphere, the northern side is your equator and southern side is your pole. Okay? North is always up. If we are making a map, always the upper side is known as north, the lower side is south, right is the east, left is the west. As you can see the map of India, Jammu and Kashmir is always north and Chennai is south, Kolkata east, Gujarat west. Okay, so accordingly this is the southern side of the northern hemisphere, this is northern side, so it decreases from south to north, from 16 kilometers to 8 kilometers. So this is again a question where you have to reason a lot. Okay, a common sense question. Alright, next. What approximately is the average height of the tropopause over the equator? 16 kilometers. In the international standard atmosphere, the decrease in temperature with height below 11 kilometer is 0.65 per 100 meters or 6.5 degrees centigrade per kilometers, which is 1000 meters. So we just increase 10, we make it 1000 meters, so this dot comes in the middle, right? All right. Now we come to the fourth question. Question 4 to 7. The 200 hectopascal pressure altitude level can vary with height. Any HPA pressure level can vary with height. So 200 HPA pressure altitude level means approx 38,000 to 39,000 feet. Okay, so you are around 39,000 feet. That is your 200 HPA pressure level. So here the 200 HPA pressure altitude level can vary with height. The temperate regions, which of the following average heights is applicable? Okay, so you have a chart. In that chart it says that all these altitudes are according to the temperate region. So if you refer to your chart, 200 will be given 390. 200 will be given 390. It is more to learn rather than to. So you will be able to answer this when we do chapter number 2. For now, you won't be able to correlate it because it is a question of the pressure chapter. So for now, just learn the figures that okay, 200 HPL pressure level at temperate regions is 39,000 feet. Okay. All right. The temperature at flight level 110 means 11,000 feet. So the temperature at 11,000 feet is minus 12 degrees centigrade. What will be the temperature at flight level 140 if the ICO standard lapse rate is applied? Obviously, we will be applying the ICO lapse rate. So what is the answer? So flight level 110, temperature minus 12. What will be the temperature at flight level 120? Minus, we are talking about standard ICO, not outside air temperature. The standard, so the standard temperature at flight level 110 is minus 12. So when we go up 1000 feet, then what will happen? How much it will decrease? Do you know the lapse rate? What is the lapse rate? So will it decrease 2 degrees? Yes. So at flight level 120 it will be minus 14. Flight level 130 it will be minus 16. And flight level 140 it will be minus 18. So minus 18 is your answer. Alright? Okay. At a certain position, so here they are not calculating from bottom 15 degrees. They are directly calculating from flight level 110. 110, the ICO temperature is already given. Okay. Or maybe ICO temperature is not given, but a temperature is given at flight level 120. They are saying on this you have to now apply the lapse rate, which is the ICO lapse rate. So on this we will apply the ICO lapse rate, not on mean sea level. If it was not given, it was just given just taking the default conditions, then we would have started from 15 degrees. Then from 15 degrees we would have come to flight level 110, whatever the temperature would have been, and then from there we would have gone to flight level 140. But here already temperature at 110 is given. They are asking us to apply the lapse rate over this. So we'll just do 2 degrees per 1000 feet. Alright? Okay. At a certain position, the temperature on the 300 HPA chart is minus 54 degrees centigrade. Okay. So let's say at 30,000 feet, 300 is 30,000 feet. Let's say there is a chart, and at a particular point in the chart, the temperature is minus 54. At this point, the temperature is minus 54 degrees centigrade. Okay. And according to the significant weather chart, the tropopause is at flight level 330. Okay. So tropopause is here. This is at 30,000 feet. Okay. And this is 33,000 feet. This is 30,000 feet. Here is 30,000 feet, here is 33,000 feet. So at 30,000 feet we have tropopause, TP, tropopause. Okay. What is the most likely temperature at flight level 350? So here, 35,000 feet. Okay. So at 30,000 feet, what is the temperature? Minus 54 degree centigrade. Okay. At tropopause is at 33,000, that is 3,000 feet above this. So what will be the temperature at 35,000 feet? So see, this actual temperature is already given. At 30,000 feet temperature is minus 54 and tropopause is at 33,000. That means lapse rate will apply till tropopause. So at flight level 31 it will be minus 56, 32 it will be minus 58 and 33 it will be minus 60. So at tropopause now the temperature is minus 60 and it will remain constant till 20 kilometers. Okay. So here also the temperature is minus 60. So these are a little bit of reasoning questions. In the beginning you may find it a little confusing, but once you do it, then IC Joshi also becomes very easy for you. And once you understand this, you can at least score 90% in your exam. And if you only score 90%, you are going for flying. Below that, you are not. Otherwise, you are getting a rickshaw. Okay. We will not give you that pedal one, we'll give you the E one. Okay. It has a great market these days. Okay. Next. What is the boundary between the troposphere and the stratosphere called? Tropopause. This is a very easy one, right? Okay. Okay, now let's come to question number 8. Which constant pressure altitude charge is standard for 4781 feet pressure level? Pressure level, flight level, that is 5000. So again you will get this in the next chapter. Okay. So you will study there that at what altitudes there are what pressure levels. Okay. So ground is mean sea level, right? Ground will be mean sea level. After that, once you start climbing, you reach 5000 feet at 850. Then 700 HPA is 10,000 feet. Okay. And let me show you that chart, if this chart is there in this book. You can write down this chart, a lot of questions from this chart. Write down this. Flight level 50 or 5000 feet, pressure level is 850. So from the ground, when you go to 5000 feet, the default pressure according to ICO standards will be 850 hectopascals. Okay. 700, 10,000, which is also flight level 10. 500, 18,000, flight level 180. 400, 24,000. 300, 30,000. 200, 38,000. And 100, 53,000. These are not the exact numbers, these are the ones rounded off. Alright, so what is the pressure level at flight level 50? 850 HPA, right? Okay, and outside air temperature of minus 30 degrees centigrade is measured while cruising at flight level 200. What is the temperature deviation from the ISA at this level? So flight level 200 means what altitude? So it just means that at 38,000 feet temperature is, the temperature is how much? Minus 30 degree centigrade. What is the temperature deviation from the ISA at this level? So let's try to calculate the ISA temperature here. So at 38,000, how we will calculate? 38 into 2, right? Plus 15. This will be minus. 38 into 2 is how much? Oh, sorry, it's not HPA. So sorry. It is flight level 200, not 200 pressure altitude HPA. It is 20,000 feet. I'm so sorry. So at 20,000 feet, flight level 200 means at 20,000 feet. At 20,000 feet, how much is your temperature? 20 into 2 minus plus 15 is equal to minus 40 plus 15. That is how much? Minus 25. And what is the temperature? Minus 30. So what is the ISA deviation? Yes. So it is 5 degrees colder than the ISA. Okay. What is the most likely temperature at the tropical tropopause? We studied it yesterday. Tropical tropopause में what is the temperature? Plus 75? So don't say 75, say minus 75. Okay. Which one of the following statements applies to the tropopause? Is it isothermal? It indicates a strong temperature lapse rate. It is by definition a temperature inversion. It separates the troposphere from the stratosphere. Yeah, D. Okay, next question. In the lower part of the stratosphere, the temperature is almost constant, decreases with altitude, increases with altitude, increases first, decreases afterwards. It is almost constant, yes. Very good. Next. What is the appropriate composition of the dry air by volume in the troposphere? This is an easy one. So yes, it's an easy one. How does temperature vary with increasing altitude in the ICAO standard atmosphere below the tropopause? So this is tropopause. Below tropopause, what happens? Temperature increases with height or decreases with height? How does temperature vary with increasing altitude in the ICO standard atmosphere below the tropopause? Yes, tell. Normal lapse rate. Below the tropopause, normal lapse rate decreases at a rate of 2 degrees centigrade per 1000 feet. Okay. Now we come to the 15th question. Now this is the problem, na? I just came to 22. Where is the missing questions? 14, where is the 15? Okay, coming back to question number 15. How would you characterize the air temperature of minus 15 degrees centigrade at the 700 HPA level over Western Europe? It can be over Asia, Western Europe, anywhere, doesn't matter. The question is at 700 hectopascal, that is at 10,000 feet, if the temperature is minus 15 degrees centigrade, then is it ISA, colder than ISA or hotter than ISA? How we will calculate? So it will be again 2 into 10 minus plus 15, which will be minus 20 plus 15, which would be minus 5. So ISA here is minus 5, but actual is minus 15. So this is approximately 10 degrees below standard. So you can just say low. Okay, you just say low. Best of the 4 answer. It is not high, it is not within 5 degrees, neither is it is 20 degrees below, it is just 10 degrees below. So we'll just go with low. Okay, next question, 16. If you are flying at flight level 300, that is 30,000 feet, flying at 30,000 feet in an air mass that is 15 degrees centigrade warmer than the standard atmosphere, what is the outside air temperature? So how we will calculate this, tell me. So first let's know the standard. Standard at 30,000 will be 2 into 30 minus plus 15. So that is how much? Minus 60 plus 15. So that is minus 45. So minus 45 is the temperature. Okay. Now it says it is 15 degrees warmer. So 15 degrees warmer means plus 15. It becomes minus 30. So what is the outside air temperature? Minus 30. Does it make sense? But you guys didn't answer it. Why? Brain fog? Okay. If you are flying at flight level 140, the outside air temperature is -8, what altitude will the freezing level be? What altitude the freezing level means at what altitude there will be 0 degree centigrade temperature. Whenever you find 0 degree centigrade temperature, that is your freezing level. So yes, tell me. At flight level 140 temperature is -8. So at what it will be 0? Yes, flight level 100, very good. Because flight level 140 is -8, 130 will be -6, 120 will be -4, 11 -2, 100 will be 0 degrees. So your answer is B. Lot of people will put 180. They further decrease. We don't have to decrease, we don't have to make it -16. We have to increase it. Okay. So this was a good reasoning. So yeah, one kacha mango to you tomorrow. All right. What is the most important constituent in the atmosphere from a weather standpoint? Most important constituent of atmosphere from a weather standpoint. Water vapor. Because this water vapor is the main guy which does it all. Sometimes it makes you feel so good, sometimes it just kills you. Beware of the water vapor. The average height of the tropopause at a latitude of 50 degrees is about 50 degrees middle latitudes. Middle latitudes, what will be the height of tropopause? (11 kilometers). Very good. Between mean sea level and a height of 20 kilometers, the lowest temperature in the international standard atmosphere is 20 kilometers. So from mean sea level it is +15, till tropopause 11 kilometers it is again -56.5, 20 kilometers again it's the same, -56.5. That's the lowest temperature. Cannot have it below this. After 20 it will start increasing, it will not decrease. Okay. Question 21. The international standard atmosphere assumes that the temperature will reduce at a rate of the international standard atmosphere assumes that the temperature will reduce at a rate of, we know it. Come on, speak up. Option A. Yes, you are correct. So this is 11 kilometers and it remains constant till 20 kilometers, which is your 65 6 months. 7. B is not applicable because first it will be constant, then it will increase. Okay, alright. Good job, guys. There are slight chances that you guys score 90%. Okay, so we have last 3 questions in fact. Then we are done. Okay. In the middle latitudes, the stratosphere extends on average from middle latitude, stratosphere is from 11 to 50. In the book it is given 11 to 50. It doesn't mean they are talking about equator or poles, they are talking about the temperate regions. Okay, yes, they are taking the average. Okay, next question. In relation to the total weight of the atmosphere, the weight of the atmosphere between mean sea level and height of 5500 meter is approximately. So yeah, this is a tricky one. So how we don't know what is the total weight of the atmosphere, but from 0 to 5 kilometers, you should know that half of the weight of the atmosphere reduces. So atmosphere is a fat guy weighing 100 kgs in mean sea level. Take him to 5,000 feet, like 5,500 meters, sorry, take him to 5 kilometers, not feet, and you see him, he becomes so thin. Okay. 24. A temperature of 15 degrees centigrade is recorded at an altitude of 500 meters above mean sea level. If the vertical temperature gradient is that of a standard atmosphere, what will be the temperature of the summit of a mountain 2500 meters above mean sea level? Okay, let's see. So we are at 500 meters. How much feet? Approximately 1700 to 1800 feet. Okay. And here the temperature is recorded how much? 15 degrees centigrade. And there is a standard lapse rate. What will the temperature at 2500 meters? मतलब we went up by 2 kilometers. ठीक है, 500 meters temperature is let's say x, and plus 2 kilometers temperature becomes y. So plus 2 kilometers में how much the temperature will change? 15 degrees minus 2 into 6.5. So that is 2 degrees centigrade. B. That's your answer. So instead of doing feet of 2 degrees centigrade, it was easier that we did kilometers, 6.5 degrees centigrade calculation. So that's atmosphere for you. And this is Captain Nipun signing off from today's question and answers. Thank you.